guys, where we ended off in our last lesson is we sort of finished off question 2. And so now what we're going to have a look at is question 3, which deals with equations. Now, equations is another very, very important section in maths. Equations, you'll start to see as we go, or as you move up in the grades, a lot of the sections start to overlap with each other. And a lot of concepts that you do in equations will come up in other sections. And equations, like I say, is one of those things that comes up a lot. We do equations when we work with exponents, when we work with number patterns, when we work with graphs. When you eventually start trigonometry in grade 10, there's equations that you need to deal with. So equations comes up in a lot of places. And so it's a very important section for us to feel comfortable in and confident in. So when we solve equations, can anyone tell me, I don't know how to phrase this, what is the point of solving an equation? What are we trying to do when we say solve for x? What does that mean? And you can raise your hand or you can pop it in the chat. Theo?
Isn't it to get the value of x?
Excellent, well done. We want to find a value of x that will make the equation true. So we'll basically make the left-hand side equal the right-hand side. That is the point of an equation. Now, the reason I'm asking this question is because this will eventually lead us into A, knowing what we actually need to do with equations, and B, it also gives us an indication of how we can always check our answers. But I'll get to that in a second. So the first thing with equations that we need to take note of is the fact that when we solve equations, we need to use inverse, sorry guys, or opposite operations. So that means I always use the opposite operation of what I originally had in order to solve my equation. I'm using my finger again, my pen's stopped. I'm going to figure it out. So that means if the equation originally was like here, minus 30, to solve my equation, I need to use the inverse and I need to add 30. So inverse operations is very, very important when solving equations. Now, if we can follow these 3 basic steps, we can solve equations. Obviously, as equations get more complex, we need to add to these steps, but the basic gist is we want to get our x's or the x terms to the left. I'm just going to use L for left. We want to get our constants, and remember those are terms that are just numbers. Obviously then to the other side, which is to the right. And then we want to essentially solve for x. And that is then all done through using our inverse operations. Right, so if we have a look at our very first equation that we have here, I've got 7x, let me just make this a bit bigger. I've got 7x minus 30 is equal to 4x minus 6. So I want to solve the equation. The first thing I want to do is I want to get this 4x term to the left-hand side, because that means I'm going to get my x terms to the left. Now, in order to do that, I have to use inverse operations. Now, this was originally a plus 4x, which means that the inverse of that, the opposite operation to that, is minus. So if I go in minus 4x on both sides of my equation, I'm going to be able to move it to the left-hand side. And so what I have now is 7x minus 4x. The minus 30 is still there. I'll deal with that in a second. Oh God, maybe I should just write it down. Minus 30. But now on the right-hand side, I just have the minus 6 because I've moved that 4x to the left-hand side. Okay, before I carry on, Theo, do you still have a question or is your hand just still up? No. Cool. Right, so we've essentially done step 1. We've got our x terms to the left-hand side. Now we want to go and do step 2 and get our constants to the right, which means that this minus 30 needs to move to the right-hand side. Sorry, I just got all distracted there. Pumuzilia, do you want to carry on this equation for us?
Yes, ma'am.
Okay.
First thing we'll have to say plus 30.
Good.
We have to say 7x minus 4 equals.
Sorry, I am eventually going to get there. Yeah, keep going.
Equals negative 6 plus 30.
Good.
Then we find the, what do you call it? The like terms, which is 7x minus 4x, which is 3x.
Good.
And then we continue on the right-hand side.
Mm-hmm.
Minus 6 plus 30, I believe it is 24.
Excellent, well done.
So we have to divide both sides by 3.
Good.
Then we say 3 going to 3, we leave with an x.
Mm-hmm.
Then we say x, it's in 8.
Good, well done. Excellent. Sorry guys, I just have to carry on down there. So Phumzile has essentially explained all of our inverse operations for this equation for this. So what we need to do is, firstly, as was said, we need to add 30 to both sides, because remember, I want to get my constants on the right. That then gets the x's on the left, constants on the right. And then Phumzile said it quite nicely, we're looking for like terms now. So all the like terms, by getting your x's on the left and the constants on the right, are already grouped for us. And so now we just have to add and subtract them. So 7x minus 4x is 3x, negative 6 plus 30 is 24. Now we want x. We do not want 3x. The goal of solving an equation is to get x alone, which means that I do not want this coefficient here. Now we know that originally this was 3 times x, which means using my inverse operations, I need to do the opposite, which is divide. So that's why I'm dividing by 3. But what I do on one side of my equation, I have to do on the other side of my equation. That keeps the equation balanced. And so I also need to divide 24 by 3. And 24 divided by 3 is 8. Okay, now guys, what's very important with equations is that there's a check, or there is a way for you to check your answers. Now, this you should be doing when you're at the end of your test or your exam, whatever it is, and you're sitting there with like 5-10 minutes to go. You go back to the equations, check equations, questions, and you go and check. So your check involves substitution. So we're going to substitute in the answer for x that we got into our original equation, and we are going to make sure that the left-hand side is equal to the right-hand side. So if I substitute that in, 7 times 8 is 56 minus 30. 4 times 8 is 32 minus 6. Now I want to check that the left is equal to the right. 56 minus 30 is 26. 32 minus 6 is 26. Because the left-hand side is equal to the right-hand side, the answer that I got of x equals 8 is correct. And so that is your check. You check that the sides are equal to each other to make sure that your answer is true, and so the equation is true. Now, you don't have to write it out like I've done it. I just wanted to show you. But it is one way to check your work with equations and to make sure that if you're not getting the left is equal to the right, you've probably done something wrong somewhere, and that means you can go and check your work. So I really do encourage you to do a check so that you're not losing marks unnecessarily. Right, so I'll wait there for a second or two if you want to take a screenshot of all of that. If you want to get started on 3.2, by all means do that, but we're going to look at 3.2 in a second. Okay, last 2 seconds if you want to take a screenshot. And let's have a look at 3.2. Right, so 3.2 now, guys, we've got something a little bit different in that we've got some brackets here. Now, brackets mean distribution or very basically multiplication. The second we see brackets, we want to multiply the coefficient or the number in front of the bracket into the bracket to essentially get rid of those brackets. We don't want brackets. It's just creating more work for us. Let's get rid of them and multiply out. So when I go and distribute that -2 into my bracket, I've got 3. -2 times x is then a minus 2x. A negative times a positive we know is a negative. 2 times 4 is 8, is equal to 5x plus 1. Let's try that again. Plus 1. Didn't get any better. Third time's a charm. Maybe it's not. Plus. Cool. I'm going to get it right now. Plus. Me and technology.
Yeah, that's the thing with technology. It's unpredictable sometimes.
Oh.
Oh, there's one.
Okay, the one eventually arrived. Okay. 5x plus 1. So now this looks very similar to what we had in the last question. So I want you guys to give this a try. I'm going to give you like 2 or 3 minutes. I want you to try and solve this equation for me and get an answer for x. What I'll do is I'll scroll up a bit so that you can see how we did 3.1 in case that helps you. We are solving for x. Remember your inverse operations. Remember to follow those 3 steps. Get x's on the left, constants on the right, and then you can solve your equation. And remember, if you finish quickly, you can do your check. Yes, when you're done, send us maybe like a thumbs up when you're done so that we know. Silungiwe, do you have a question or do you want to give us the answer?
Sorry, I actually don't understand how we got 8 from the brackets.
Okay, cool. So let's, if you guys are happy to carry on, by all means do that. Otherwise, I'm just going to have a look at the multiplication here quickly. So the bracket we had was -2 times x plus 4. And so we want to multiply that out. So that means are you happy with the -2x, where we got that from?
Not really.
Okay, cool. So let's start right from the beginning here. So basically, when we go and multiply this, I'm going to do this step by step. I've got a -2x or -2 times x because I need to multiply that with the x.
Yeah.
And I've got the -2 times the +4 because I need to multiply the -2 with the +4. So now this is where we can use the little SNV trick where we first do the signs, then we deal with the numbers, then we deal with the variables. So in the first one, I've got a negative times a positive. Now we know that a negative times a positive gives us a negative. So that's my signs done. Now I go on to the numbers. Now technically there's a 1 in front of the x. And so 2 times 1 is 2. And then I've got this x here that still needs to be there because that deals with the variables part of my SNB. So -2 times x is -2x. From there, we now need to do the second multiplication. Now, the second multiplication, again, we start with the signs. A negative times a positive is a negative. And then we go to the numbers. 2 times 4 gives me a -8. So that's where I'm getting that -8 from, by multiplying a -2 and a +4. Does that help some of you?
Yeah, it does. Thank you.
Okay, good. Okay, I'm seeing a couple of I'm done emojis, which is great. Is anyone wanting to raise their hand to explain to us how to solve this equation? If you do want to raise your hand to explain, please do. No one wants to explain. Hurting my feelings.
Come on, guys, anyone. Because you're done, which means you have done something. Let us know, how did you arrive at an answer? You're here to learn. There's one.
Okay. Theo, help us out.
So ma'am, I said -8, -3, and minus this one. Ma'am, I said +1.
Okay, so what is your first step that you're doing here?
-8 -3.
Why are you saying -8 and -3?
Because ma'am, there's a minus. So ma'am, I said I like did it from like biggest to smallest. I said -8 -3, then 1.
Which side are those all going on?
I'm on the left.
Okay, so if we're going to have them on the left, remember the 3 stays +3, then it's -8, and then because we're bringing the 1 over, it's -1. So it should be +3 -8 -1, which is fine if you want to
Okay,
put them
ma'am.
on the left. What then happens?
Then I said 5x plus 2x.
Good. Oh, sorry.
Then
Yeah.
I say -6 equals 7x.
And where are we getting -6 from? Just explain that for me.
From 3 -8, which is -5 -1, then it's -6.
Good.
Then 5x plus 2x equals 7x.
Good.
Then it's 7. I put the 7 on the left name, then it's 7 divided by -6.
Good. So what is x equal to?
-1,16. 17, ma'am.
So remember, it's -6 divided by 7, not the other way around.
Okay. Okay, ma'am, it's 0,85.
Good, exactly. Well done. Nice. Okay, so if you put the constants on the left-hand side, that is fine. It really doesn't make a difference. I just say put them on the left because it means that you've already got x equals. So some of you might have done this a little bit differently. So I'm going to show you what it might have looked like if you had put your constants on the right-hand side, but your variables on the left. So I don't know if this is going to work very well. I'm assuming that we're all happy with the multiplication. That's a little bit thick. Let's just fix that, which is 3 minus 2x minus 8 is equal to 5x plus 1. Okay. So the first thing that we can do is we can get all of the x terms to the left-hand side, which means I will have to subtract 5x on both sides. That's just shocking. Let me try that again. I will have to subtract 5x to move the 5x over to the left. So I have a minus 2x minus 5x. Now I need to do the same thing with the constants. Now there's two constants on the left. I've got a positive 3, which means I need to subtract 3 on both sides. And I've got a negative 8, which means I need to plus 8 in order to move it over the equal sign. And so what that means is I've got minus 2x minus 5x is equal to the one that was originally on the right, minus 3 plus 8. And so now I've got the minus 2x minus 5x, which is minus 7x. And then I've got 1 minus 3, which gives us minus 2, plus 8, which gives us 6. Now, I don't like the fact that I've got a negative 7 in front of my x. Sorry, it's a weird looking 7. And so what I need to do is I need to divide both sides by negative 7 in order to get x alone. And when I divide both sides by negative 7, I get that x is equal to negative 6 over 7. You can write it as a decimal if you want. I generally don't. I leave it as a fraction. But you can write it as a decimal if you want to. But x here is equal to negative 6 over 7. So if you put the variables on the right-hand side, it's fine. So as Theo did, he put them on the right-hand side. That's okay. It doesn't matter. But it does help if it's all on the left, because it means then we've got x equals whatever. Right, I'm just going to leave that there in case anyone wants to take a screenshot. Kulunga, do you have a question for us? There we go.
I'd like to ask, how do we invert the 2x and the 5x and we mix those three numbers so that we can get the answer? Those two numbers so that we can get the answer. 3 minutes.
Okay, what do you mean when you say mix the numbers?
Like when I say, how are we going to say 3? How going to event 3 to go to that side, and also event negative 8 to go to that side?
Okay, cool. So the way we do that was we use the opposite. So this was a plus 3, which means I have to use the opposite. I have to minus 3. And then the same thing for 8. 8 was negative. So to get it to the other side, like you say, I have to plus 8. So that's why now I've got minus 3 and plus 8. I've done the inverse to get them on the other side. Does that make sense?
Okay, ma'am. Thank you, ma'am.
Does it make sense, or do you want me to explain it again?
No, I'm fine, ma'am. Thank you.
Okay. Okay, so guys, those inverse operations, like I say, super important because it allows us to get the terms where we want them to be. Becky, do you have a question?
Ma'am, afternoon, ma'am.
Hi.
My question is, when you do the inverting, do the constants always have to come to the right-hand side and the? Oh, okay.
They don't have to. So you can see here the stuff written in black, the constants came to the left, but in the stuff written in purple, the constants came to the right. It really doesn't matter which side you put them on. Generally speaking, our answer is always x equals. So if we get all the x's on the left, then it's already at x equals, but it doesn't matter.
Oh, okay. Thank you.
Sure. Okay, I'm hoping we all have our screenshots. We are already halfway, so we're going to take a little break. Just need to get. So about halfway through our lessons, we'll always take a little bit of a brain break, a little bit of a break from the maths that we're doing, to chance for you to get up, stretch, move, but also a chance for you to give a little maths puzzle a try. Here's your joke for the day. A cow in an earthquake is called a milkshake. And I don't know how many of you have seen these like emoji puzzles before, but essentially what it is it's solving an equation. So it links in with what we are currently doing in question 3. We're solving an equation. Okay, so can I get a thumbs up or a thumbs down? Yes, you've seen these before and you know how to do them, or no, you haven't seen it before. So thumbs up, yes, I know how to do it. Thumbs down, no, I don't know how to do it. I just want to see how many people sort of know what's going on. Okay, cool. So I think for the first one, we'll do this together, just that everyone knows how to do them. And then from there on, hopefully we'll be fine. So guys, the point of these, oh no, that's a bit aggressive. The point of these puzzles is essentially to go and find the value of the last expression. So wherever there's a question mark, we're wanting to find the value of that expression. But in order to do that, we have to know the value of the boots, the sunglasses, and the coat. Now, you don't always have to start with the first one, but in this case, starting with the first one is going to be easy for us because we've got 3 identical things being added together to give us 42. Now, you can think of this like an equation if you wanted to. If we, it's really just going to fight me the whole way. If you think of this like an equation, if you've got 3 identical things being added, essentially you've got an x, and an x, and those are all being added together. And because those are like terms, you essentially have 3x is equal to 42. And so thinking of it like an equation, if you want to, you can go and find what the boots are worth. Shaham, do you want to tell us what the boots are? Or do you have a question?
I want to tell what the boots are.
Yeah, tell me.
Each boot is 7. So
Okay.
since there's 2 boots in each, so there are 14. So
Excellent.
14 plus 14 is 42.
Perfect. Well done. Okay, so guys, exactly. If we add 14 3 times, we're going to get 42. Now, very importantly, Shaham's told us that 1 boot is then worth 7. And so in this last expression, that 1 boot by itself is 7. And that's very important. If you've got 2 and then you only have 1, if we halve it, we're going to get the value of 1. Right, Emmanuel's then put on the chat there that 2 sunglasses is worth 10. So let's have a look at that in our next step. Now, guys, what you need to be mindful of here is that there's a times and that there's a plus. And so what that means is that you need to be careful of, or you need to be mindful of BODMAS. The times has to happen first. So Emmanuel said 10. Let's see if we agree. If these sunglasses are 10, let's apply our BODMAS and see if we agree with that. So the BODMAS says multiplication first. 10 times 14 is 140. Plus 10 is 150. So I'm in complete agreement. The double pair of sunglasses is worth 10. Now, in the same reasoning, if I only have 1 sunglasses, 1 pair of sunglasses, this is only worth 5. And so now when I head into my third equation, I now just need to figure out the value of my coats. But again, there's a multiplication and there's an addition. So I need to be careful of BODMAS. So does anyone want to try and tell me what the coats are equal to, or what the coats value is? Linneo, excellent. Theo?
9, ma'am.
9, perfect. So these coats are equal to 9. 9 times 5 is 45. 45 plus 9 is 54. Now, when we get to the 2 coats in the last one, we double 9, which gives us 18. Now, again, we need to be careful of BODMAS. Tato, do you want to finish this off for us?
Yes, ma'am. We're gonna start with 10 times 18.
Excellent.
Which is 180.
Good.
And then the final answer is 187.
Wonderful, Tato. Thank you. Well done.
You know.
Okay, guys, exactly as Tato has said, very importantly, we first start with the multiplication because of BODMAS. So we do 10 times 18, that gives us 180, and then we add the 7, giving us a final answer of 187. Now, again, these are equations. They're picture equations, but they are equations. And so this helps us hopefully gain a bit more confidence in sort of working out equations. I don't know if anyone wants to screenshot it, but I'll leave it up here in case you do. And then we will continue on with our algebraic equations versus picture equations. Okay, let's do it. Right, so the next equation we're going to have a look at, and I'm almost tempted to give us a bit more space here, so let me just do this. The next equation we're going to have a look at is one where there is an equation. No, it is an equation, a fraction. That's what I'm going for. Okay, so we have got a fraction here of x over 2 minus 3 equals 7. So my first question is, and you can quickly put it in the chat, what operation does a fraction represent? Tato?
It represents division.
Good, so stay there for me. If we then want to do the opposite or the inverse of division, what operation should I do?
Multiplication.
Excellent, well done. So guys, fraction is division. It represents the operation of division. And so in an equation setting, if I now want to do the inverse operation, I need to use multiplication. Okay, so let's try this one together. You can start wherever you want. I like to just move my terms where they need to be. So I'm going to keep the x over 3 on the left-hand side because I'm fine with that. Not over 3, over 2. So sorry. But what I am going to do is I am going to now move this -3. Now to do that, I have to add 3. And so what I have is x over 2 is equal to 7 plus 3. Now we know that 7 plus 3 is equal to 10. And so we've got x over 2 is equal to 10. Now, as Tottle's told us, the opposite of division is multiplication. And so now in order for me to deal with this division by 2, I have to times by 2, and that will get rid of that division. But I can't just do that on the left. I also need to do that on the right-hand side. And so if I times 10 by 2, I get that x is equal to 20. Oh, that's a weird looking 0. 20. Now again, you can go and check yourself. If you go and substitute 20 there into your fraction, 20 divided by 2 is 10. 10 minus 3 gives me 7. And so x is equal to 20. And so be very careful when you are doing your inverse operations, especially when it comes to multiplication and division, that you're applying it to every term. Okay, so Oratila's question said, if we add 3 to -3, isn't it 0? Yes, it is. And that's essentially why we do it. So on the left-hand side, those cancel out. But remember, what we do on the left, we have to do on the right. So it eliminates the 3 on the left, but it brings it back in its inverse form on the right-hand side. And so that's why the 3 essentially disappears from the left-hand side, because it does equal 0. Well done. Okay, I want us to try another one. I'm gonna at least, well, hopefully I remember this. Yeah. Okay, sugar beans, let's try this. 3x plus 1 is equal to 4. So I want you to try this by yourself. I'll leave 3.3 there so that you can sort of follow it along. I want you to be careful of the fact that there's a fraction. I want you to take note of your inverse operations. And so what I want is the value of x. If you want to raise your hand and let me know how you did it, you can. Obviously, I'm going to give you some time to try it. But we're solving for x here. Kabiso, do you have a question?
No, I've got the answer.
Okay, I'm going to give everyone another minute or two, so just keep your hand raised and I'll ask you in a second.
Perfect.
Nabutle? Throwing a span in the works. Okay, I'm going to give you another minute, and then Kabiso is going to explain to us how we do this. Okay, Kabiso, tell us, what do we need to do?
So basically on the left-hand side, we have 3x over 4 plus 1. So the positive 1 is going to cancel out with the negative 1 because negative 1 would be the inverse of positive 1. And then the negative 1 would be placed on the right-hand side where 4 has been placed. So 4 minus 1 is equal to 3, which is what we'll have on our right-hand side, whereas on our left-hand side, we should currently have 3x over 4. The 3x over 4 is going to be multiplied to 4 over 1, which is equivalent to 4. And the same is going to be done on the right-hand side, meaning that we're going to write 3 times 4 or 3 over 1 multiplied by 4 over 1.
Cool.
This will then equal, on your left-hand side, you will currently have 3x equals 12. And because we still have the coefficient that is linked to our x, we're going to divide that. We're going to divide both 3x and 12 by 3 to get x on its own. And then 12 divided by 3 is equivalent to 4.
Excellent, well done. I have found the person that I'm going to ask to teach my classes in future. That was
I was thinking the same thing.
That was wonderful. Well done.
Yeah, and well explained.
Yeah. Okay, so guys, essentially we follow the inverse operations. Now, again, fractions, inverse of a fraction is to multiply. I don't want to say it's spanner, but the additional thing that we needed to bear in mind was this 3. Because there was, as Kabiso said, the coefficient to the x, we still need to deal with that. And that means we need to divide both sides by 3. That was a little bit different to what we had in 3.3 because there was no coefficient. So as long as you are remembering all of your inverse operations and you are remembering that the entire purpose of solving an equation is to have just x alone, you will be fine. Right, I'm going to leave it there for a screenshot. I'm also going to see or give everyone a chance if you have any questions that you want me to go over or re-explain there. But take your screenshots. Tato?
Yes, ma'am, I wanted to ask, Why do we multiply by 4?
Okay, cool. So we multiply by 4 because of the fraction that I had. Now the denominator in my fraction was 4. So essentially what that fraction is saying to me is that I'm dividing by 4. The opposite operation then is to times by 4. And so I have to times both sides by 4 so that I can cancel that denominator.
Okay, ma'am. Thank you.
Good. Right, Rebecca, I saw your comment in the chat. Whilst leaving out steps is not necessarily a problem, if it is an important step, just be careful. Obviously, we can make this working out a little bit shorter the more confident we get with equations. But just make sure you are showing your inverse operations. Okay, guys, I'm assuming we all have that. I'm gonna scroll on over. Right, so 3.4 is not one that I want you to stress too much about, but it does show us another important inverse operation that we need to be mindful of. So 3.4 is x cubed equals 64. Now, can someone explain to me what that exponent means? What does x cubed mean? Might be easier to raise your hand, but you're welcome to type it in the chat if you want. Pumazelia, what does x cubed mean?
Ma'am, I think it just simply means x times x times x, x cubed.
Perfect.
That
okay,
thing
so,
is,
yeah, keep going.
it's multiplied by itself 3 times.
Perfect, well done. So x cubed is exactly the same number multiplied 3 times. X times x times x, as Pumazelia said. And so the reason it's important to take note of is because when solving an equation like this, essentially what we're asking you to do is think of one number that when I multiply it 3 times, I'm going to get 64. Now there is an inverse operation that we can deal with here, which I'll get to in a second. But that is essentially what this equation is asking you to do. What is the one number that when I multiply 3 times, so 2 times 2 times 2, or 7 times 7 times 7, is going to give me 64? Shaham, do you want to tell us?
Yes, ma'am. The answer to that is 4. 4 times 4 times 4 is 64.
Excellent, well done. So in this case, x is equal to 4. Now, does anyone know what the inverse of cubing a value is? Kumuzile?
Is it square? No, cube roots.
Perfect, well done. So guys, if you're going to do this on a calculator, you can. We just cube root. And so what a cube root is essentially canceling or doing the inverse of cubing something. So when we cube root something that is cubed, the cube and the cube root essentially cancel, leaving me with just the x. But again, it's an equation, so I need to remember to cube root 64 as well. Now, some of you might not have a cube root on your calculator, some of you might. If you've got like a Casio calculator, and I think even the Sharp calculators, it looks quite similar. I'm going to do my best here. Right, there's a square root. If you look on top of the square root, there's a little yellow cube root. So what you'd have to do is you'd have to push, maybe I should turn my calculator on. You'd have to push shift and then that button, and that gives you the cube root. Then you can type in the value that you're wanting to find the cube root of, and your calculator gives you 4. So there is a cube root button that you can use. You might have to push the shift button to do that, just bear that in mind. But that's if you want to use a calculator. If you don't want to use a calculator, that's fine. You then do exactly what we said. What is the same number that I multiply 3 times to get my answer? Some people are a lot more confident with cubes and squares than others, which is why a calculator potentially is quite useful to you. But it's one number that we multiply at the same time. And then, like I said, you could potentially use your calculator if you wanted to. Again, I'm just waiting here in case anyone wants to take a screenshot. Right, and then you guys are so on it tonight. I'm going to give you, let's call it a step up equation. Right. Let's hope my maths is on it. Right, there is 8 minutes left of this lesson. I'm not going to give you all 8 minutes because obviously I want to give you the answer. I'm going to give you 2 or 3 minutes. I want you to try this equation that I've typed out here for you based on everything that we have spoken about today. Be careful of where the fraction is. Be careful of your inverse operations. If you're feeling brave and you want to give us an answer, please do. Because it's so fast. It's awesome.
Fast. It's very impressive.
Yeah. I can't even do maths that fast sometimes.
No.
Okay, any of you with answers coming through, do you want to explain it to us? Oh, there we go. Ooh.
Oh, we have Theo.
Okay, Theo, tell us.
So ma'am, I said 3x plus 1 divided by 2 plus 2 equals 7. Then I said in the next step 7 minus 2. Then I said 3x plus 1 divided by 2 equals 5. And I said in the next step 5 times 2, ma'am.
Yeah.
Which is 10. Then listed by 1.
Okay, hang on, I'm catching up. Right, so now we have to subtract 1. Okay, keep going.
Then I got 9.
Yeah.
Then I said 9 divided by 3. Then I got 3.
Perfect. Well done. Oops, maybe I should write the right thing here. Very, very well done, guys. So again, like the spanner that I threw here is the fact that you had the +1 in your numerator. And so only after you had subtracted 2 on both sides, and after you had multiplied away that denominator, you then had to then again subtract a 1 in order to start getting that x by itself. And so the more complex our equations are, we need to still be careful of all of our inverse operations. But that was excellently answered. Well done. And everyone else who got that x equals 3, very, very nicely done.